We're going to be talking a little bit today about JTAG debugging with the ESP32. I've not done a massive amount with this actually. I bought one relatively recently, and so what you're learning today is what I've learned in the last week or so of having a play with this. So it definitely won't be a deep dive. And in fact, there's a heap of videos on YouTube if you want to deep dive into JTAG itself. But yeah. We'll see. So this is a little bit about me. I'm Pete Gallagher. I'm a freelance software developer. I spend quite a lot of time in the IoT space, which is what I enjoy doing. I've been doing that for years now, all the way back to making an internet connected Royal Mail stamp vending machine years and years ago. But I've always enjoyed IoT. It's paid the mortgage. I'm also an Azure MVP and a newly minted Pluralsight author as well. Not that I've produced any videos yet, but I've gone through the audition process and passed that, so that's pretty cool. I'm also a dad to two little girls who have only just gone to bed, so there is a good chance that there'll be some noise at some point when they decide that it's still not bedtime, but it is. So so moving on a little bit. What we're going to be doing, I'll look a little bit about the ESP32 itself. It's a cool little device. And then briefly about JTAG hardware debuggers and what they are. And then I'll just show you how they connect up to our ESP32 board. And then I'll spin up a simple app just so we can get a baseline about where we're starting from in the Arduino IDE that we all know and love if you do any IoT work. Then we'll look at what Visual Micro is in Visual Studio 2019, and then we'll look at PlatformIO in VS Code, and then we'll do a bit of debugging of our app in those just to see how that works. And then we could do a bit of Q&A in the chat if anybody asks any questions in there, so we can do that. So. The ESP32. So this is a microcontroller-based IoT piece of kit by a company called Espressif, and it's got a bunch of stuff on board. So what's special about the ESP32 is that it's got Wi-Fi and Bluetooth BLE built in. So you can't quite see it on that image, but there's an antenna that I'm pointing to where Wi-Fi and BLE are highlighted there. And then, as I say, it's a microcontroller, so it's not like a Raspberry Pi, which is a full-on computer. This is a lower level beast that we're going to be programming in C, although you can do it in Python, and there are versions out there that let you even do full .NET standard. It's got a micro USB socket on there for you to be able to hook it up to the computer and program it, and that also doubles as a serial interface, so you can do simple debugging through there, sending serial messages back to your PC. There's a handy little built-in LED that we're not going to be using today, and a whole heap of GPIO. It's dead cheap. In fact, if you're willing to get them from China, it's less than £7. But if you go on Amazon, then you can find them for about £7, £7 or £8-ish, and next day delivery. It's a dual-core microcontroller as well, so pretty powerful for that £7, and clocked all the way up to around 240 meg as well. It's got, depending on which kit you get, but the standard kits have got around 4 meg of flash memory for you to play with. You don't get all of that depending on what you specify, because you can do things like over-the-air updates and some other bits and bobs in there as well. So you don't always get all of that, but depending on what you turn on and turn off, then you can. Roughly 512k of RAM. It's got an RTC in there, real-time clock as well, and that's got some RAM built into it as well, which I've found quite handy, depending on... you got speed? Oh, okay. Yeah, that's good. People can hear me. That's good. Hey, Cliff. How's it going? Yeah, so you've got 8k RAM in that SRAM, which I found quite useful recently when playing with trying to get Wi-Fi and Bluetooth to work together, and yeah, that's painful. Actually, turning on Bluetooth kills the Wi-Fi, so you have to restart the whole ESP32. I'm not quite sure why that is, but I know they share the antenna, but you can turn one off and turn the other one back on, but it seems to kill it. And then killing the Bluetooth means you've got to restart it, so a little frustrating. It's also got an E-squared on this dev kit, so that'll maintain its state even if you restart it. There is a downside to that in that you get between 10 and 100,000 read-writes to one of those things, or write, erase, and cycles, really. So you do have to be a little bit careful. You can't constantly use that as a storage mechanism. It's 2.4 gig Wi-Fi, so no, it's not got the higher band Wi-Fi on there, just regular Wi-Fi, but I mean, what do you expect? And Bluetooth and BLE together. So yeah, it's pretty powerful. A whole heap of GPIOs you'd expect, with SPIs and I2Cs and PWMs and stuff like that as well. I've broken out some of the GPIO. There's a whole heap of stuff in there. You can even do touch inputs and stuff, but I've kind of left that off. But you can get an idea of what's there just by looking at this. You can see the closest boxes to the ESP32 just show you the numbered GPIOs that you can use as I/O. The green ones specifically, you're free to use. The other ones tend to double up as other things on the dev board specifically, and they've attached some components to some of those pins. Like down on GPIO 2, that's where the internal LED is connected to. So you don't have access to all of them. So I've highlighted the ones in green that we can freely use without having to worry about upsetting anything else. And then you can see a bit further out where we've got things like the SPI and the I2C connected in there as well. So yeah, those ones I've just flashed there, they're the ones we can use. So moving on to the JTAG debugger. So JTAG actually stands for Joint Test Action Group, which tells you absolutely nothing about what this thing does. But what it does is it replaces what was a bed of nails test mechanism, essentially. So back in the day when you used to have big 74LS components on a board and lots of nicely spaced out tracks that you could easily get access to, and you could put nice test points on there. For the manufacturing process, they used to be able to attach a whole heap of test equipment to the top of these nicely spaced out boards to be able to exercise all of the I/O and make sure that everything was working, so they could pass either the blank boards or the populated boards off as part of the QA process. But obviously, as things have gone on, these things have become smaller and smaller and smaller, and we have less and less access. And in fact, some chips now you can't even get to the pads because they're actually underneath the chip. So, and this is a problem that's been going on for quite a while. So this Joint Test Action Group thought that what they could do is build in some functionality into ICs to allow you to be able to exercise these chips directly. So it allows you to be able to read and write values inside the chip, register values, and turn on pins and turn off pins and things like that. That's really what it was developed for. But we can also use it to set breakpoints and step through code, which is the exciting part for anybody who wants to do any Arduino programming, because debugging Arduino can be painful, to say the least. And this JTAG device gives you the facility to do that. There are other ways you can do some serial debugging, but you're quite limited in what you get to do. It uses serial communication under the hood, but it's not like a protocol that you'd be able to pick up, because each chip manufacturer is going to do something slightly different. So you end up having to buy a JTAG device that suits the chips that you're dealing with, here or there anyway. It connects to a set of pins, certainly on the ESP32, but there are a set of unique pins that are a standard, an IEEE standard, and I'll show you those in a minute. And then the device itself, the JTAG debugger, plugs in via USB back to the PC. And then on the PC, there's a piece of tooling called OpenOCD that the various pieces of software then use to communicate in and out. I've got these little wires, which you'll see in a minute when I switch scenes, to connect my board up between the JTAG debugger's outputs, I/O, and on then to the ESP32. So these are the pins that I mentioned earlier. We have a clock pin and an I and an O pin, inputs and outputs. And then the other pin there, that TMS pin, I think is just used to enable clocking. And then we have ground and 3 volts that we can power other boards from that as well. They're connected in to some of the I/O, the GPIO on the ESP32. So there's some more GPIO that you can't use. But I've color coded the boxes and arrows there to match what I've actually got on my board. But you can see that we're using GPIO 12, 13 and 14 on the left hand side, and then we've got 3 volts and ground, and then GPIO 15 then on the right hand side. There's an interesting thing about that TDI connection onto GPIO 12 can cause a few problems, and I'll mention this again later, but if you hold that high, I think that stops your whole ESP32 from booting. So it seems to be okay once you've got it running, but the first time you try and do it, you might find that you get a waiting for packet error, and that's because that pin's not doing quite what it is supposed to be doing at that point. So I'll come back to that in a little bit. I've got a really simple circuit here with an LED and a button. This is pretty much the standard Hello World circuit that you'd wire up to any piece of IoT stuff to make sure that you can read inputs and set outputs. So nothing particularly complicated. So moving on just a little bit to Visual Micro, to the first piece of tooling we're going to look at. And I'll talk a bit about it first, and then I'll switch over to the bits so that you can see it. But this is a Visual Studio 2019 extension that you can use with just serial debugging without the actual JTAG device, which is pretty cool. And you can set breakpoints in there, and it gives you some of the functionality that I give you here, actually. And in fact, in some ways, it gives you some more functionality that they're busy baking in at the moment. But just to be able to do this level of debugging without the actual hardware debugger here is pretty important, and it really does give you a good base level to start from. It supports hundreds of boards, and we're just going to be looking at the ESP32 today, but obviously there's the 8266, and I think you can do it with the Arduino Uno and pretty much anything you like. It works in 2019 and 2017 as well. And allows you to set breakpoints, and you can view the variable values, and it's now free. It's not really free. They do still want you to pay. If you want some level of support, then you go ahead and pay, and I've not done that yet, but I certainly will be doing. I know Clifford, who's watching there, I think he bought it recently, and in fact it was Clifford's talk that I saw recently, which if you haven't seen, then you do need to go and watch, where he highlighted this particular tool. So thanks for him for mentioning that. So also sneaking ahead, PlatformIO. So if I switch across to this, above my head you will see my circuit, and in fact switch back to here and we can have a look at the Arduino IDE first. So had it for years, Clifford's saying. So I didn't know anything about it, which is amazing. But to be fair, most of my time was spent with the Raspberry Pi, so that's a completely different experience. But I'd certainly played with Arduino quite a lot, but I've just not taken it to that sort of a level. So this is a really basic program here where we're just initializing a couple of variables here, counter, and then whether the button's been pressed or not, because it just makes it a little bit easier. If you've not done too much Arduino stuff, there's always a setup function that gets called before anything else when the Arduino first turns on. What's the JTAG board you have? I got disturbed by the Wi-Fi. Okay. It's an ESP prog. It's the Espressif one directly. So when we get to the end, I'll go and give you some links. I'll pull the browser on there, and we can have a look where they are. But I had to go to DigiKey to get it. I couldn't get it from Amazon, which meant I had to import it from America. But DigiKey were awesome. It was really good. This the setup routine here, and I've got the pin mode set here so that I've got my LED pins and output for obvious reasons, and my button pin is an input with a pull-up. So instead of having a resistor, which I could have done, tiny little resistor, I could have done that myself and done the pull-up, but this particular Arduino has pull-ups that we can set. So you pull the pin high naturally, and then one side of the button is high, and the other side of the button is low when you press it. So that's what we'll see. The next part of the code, you just have a loop. and this is, because it's a microcontroller, this is how microcontrollers work. They go in a constant loop. So we check the button state here by reading the button pin. And then if the button is high, then we set the LED to low and say that the button isn't pressed. Now, I know the logic kind of seems a little bit backwards, but this is where the button isn't actually pressed, because as I say before, when it's not pressed, it's been pulled high. So that's what that part's doing. And then we have, if you have a low, so not high, then we set the LED to be high at that point. Actually, that's not going to work. There it is. LED to low and LED to high. Brain fade. And then if the button wasn't already pressed, then we set it to be pressed now, and then we increment that counter. So obviously we can program that into the device, and we might as well do that now. And this is always slower than you'd want when you're demonstrating these things live, but it's not going to take too long. So I have to compile it first, obviously, link all these bits together, not that there's many bits, and then copy that serially over to the device. Obviously, in Arduino Studio, you're going to need to set a bunch of stuff in here, including, and I'm not going to go into great detail about that, but you'll need to download the ESP32 board. It's not a standard board that you're going to have in Arduino Studio, so you need to download that. But there's heaps of tutorials out there for getting started with that, so I wouldn't worry too much about that. I've set this ESP32 dev module, and that actually refers to the official Espressif dev module, but I'm not using one of those. I'm using a C-Cool one, but they're pretty much the same. There's also a Do It one further down somewhere else that is also very similar, but this ESP32 one gives you all of these extra options that you can play with. So you can set different CPU frequencies, and this partition scheme is what I was referring to earlier. So we've got 1.2 meg for the app there and 1.5 meg for spiffs. I forget what spiffs is, but you can set some other ones in there. So no over-the-air stuff and 2 meg of app, and you can have this huge app where you get 3 meg of app and only a meg of spiffs. So you've got some options there that you wouldn't get if you chose some of those other varieties. So that's programmed in, and if I just... So yeah, all right, but yeah, you can see I've just wired up a button to an LED there, and I've put a bunch of components in the middle. Not particularly complicated, but needs must for the setup that we've got there. As I say, we could have a bunch of serial stuff in here if we wanted to help us to debug this, because we need to be able to see perhaps the counter value, and we can stick that out through the serial log. So yeah, that's what you could do there. I'm not going to bother demonstrating that, because if you've done any Arduino programming, that's what you'll have been doing. Not particularly complicated. Good. So if I switch now and we look at Visual Micro, so very similar looking code I've got here, where I've got my LED pin and button pin and a counter, and then I'm setting this lot up again. So I've got an output for the LED pin and an input pull up again for the button pin. So I don't need to explain all of this again. This is exactly the same, and I can obviously program this from here, which I will do. And while it's doing that, this Visual Micro is an extension that you can just go ahead and grab from the extension store here, or you can download it from their website as well. Oh, my PC's doing that. This is not what I want to do, extensions. There we are. So you can just do a search in the Visual Studio extensions library there for Visual Micro, and then you'll get this Arduino IDE, which is its old name. They've not changed that name. Well, essentially maybe it is called that and it's by Visual Micro, but either way, this, you just go and grab that and you can install it straight from there. So one of the real good things about them is they're really responsive in their forum. I had a couple of problems and they came back and fixed one immediately and told me I was an idiot for the other one. Well, they didn't really, but I was an idiot for the other one. There's quite a lot of information to absorb when you're trying to do this. So yeah, so I've already got this installed, and what you can do then is, once you've got it installed, and I'm not going to do that right now, that's still uploading over there. It was stopped because I was in the extension studio there. Let's let that finish. So that's doing a very similar job to what Arduino IDE was doing. So that's just pumped that straight on there. And should be able to see that above my head is still working now. So that's that same code. But once you've got it installed, then we have some new project templates that you can choose from. Come on, PC, you can do it. Boom, boom, boom. And there we are. Straight away we get them. So you can create an Arduino library project, or a shared code project, or just a blank Arduino project, which is what I did. And once you've done that, then you can start coding straight away, or perhaps you just want to import some of the code you created already. I did try quite a complicated project and just copying and pasting code in, but it didn't seem to like it very much. So I think you're better off starting with a blank project and doing it that way, if you possibly can. So this is actually downloaded the debug version of this code directly into the Arduino, into the ESP rather now. And you can tell that because of the debug setting that I've got up here. It's the standard Visual Studio debug setting, but it honours that and gives you the debug version of code. Now, I've got the version of Arduino that I'm going to be using, 1.6 or 1.8. And again, I've selected and I know this might be a little bit small on your screen, so apologies for that, but you don't really need to see the words, but you can see where I'm going here. This is where we've selected which module we're going to be using, and then which COM port that the actual module is connected to. So I'm on COM6. Then to the right of that, we have the debugging side, and there's the serial side here, which I'm not going to show you actually, because I've got the hardware debugger, but this is where you can set it to use the serial debugging directly from the chip without the JTAG device, which will give you a lot of what I'm going to show you here anyway. But I've chosen hardware and I've selected my ESP32. In fact, I think some versions of the dev kit itself have JTAG debugging built in. Mine doesn't. That's what you get for buying the cheapo Amazon one. But you know, it's only about £7 for about £9 I think for a JTAG debugger, so it's not too bad anyway. So select that, and I turn off the optimization, because if you leave that on, then all sorts of variables start disappearing. So I leave that on, and then over here, where behind my head, if I scroll that up a bit to just above my head, maybe move out of the way. There is some settings in here to disable optimization as well. There's a really good tutorial on the Visual Micro website to be able to help you to get set up, and again, I don't want to deep dive too much into getting everything set up here, because there's tutorials for that, and perhaps I can come back and start from scratch on projects, but I really just wanted to top level for today. So once you've got those things set up and you've stuck your code down on there, then I've configured this. I've added some buttons to this to give you it, but you can do your building here, and you can also upload the last build. So if you just want to upload just a build on its own without having to go through that whole build process, then you can do that quite easily there. So if you say switching between ESP32s, and that gives you that facility just a bit faster. And you can just set it off to do that whole process of build and upload here directly. But I've inserted this attached to process. And if I do that, then what this does is use the JTAG debugger and hooks Visual Studio up to that, assuming everything works, because we are doing this live. Then now we are essentially debugging. And I can put a breakpoint in, and the code stops. Woohoo! Oh, that worked. So that was good. And you saw how quick that was. And my PC's been particularly slow because I'm doing an OBS broadcast to Twitch, so you can imagine that that's caning the processor on my tiny little Surface Pro 7. But once that code stopped, then we can step through with F10, and we can see that this button state, if I hover over it, that's 1, which is high. So it should step into this next piece of code, and it's going to tell the LED to go low. So we can F10 over the top of that, and the LED goes low. We can't see it because it's not doing anything. And then we set the button press to be false. And then this actually steps into some underlying code here at that point. But I'll press continue and it'll stop again. And we can hide that breakpoint. Let's just run that and just make sure that everything is still working the way we expect. We should be able to press the button and we see the LED above my head going on and off. And if I stick another breakpoint in here and we do the button, then we stop in now when we press the button. And obviously we have a counter, and we can see now I've got to 23 now. I'm not doing any debouncing here whatsoever. So when I press and release that button, it's likely that the noise on that particular button is going to be triggering that multiple times. So I know I didn't press it 23 times, but that's the reason why that's gone as high as that. But I'm going to scroll down a little bit, and we can see that the button press is now 0 and counters 23. And when the button changes true, button press changes to true, then that goes to 1. So that's all very good. But let's add another breakpoint in there. And so I've read the button state now. And if I click over onto locals, then we should have button state in there. And I can change that to 0. And let's stick another one of those in there. And if this works, then there we are. So you can change the values of those variables as you're running as well, while you've stopped, obviously, which can be really useful for any amount of debugging you want to do in case, you just want to force it down a particular path or whatever. I mean, this is standard Visual Studio debugging that we're doing at this point, so nothing particularly complicated, but it's just really handy to be able to do that. Now, obviously, we can't see how it says optimized out, so I would have thought that wouldn't have been optimized out, but yeah, I'm not quite sure why that is for that button state there, being as I've not gone in the optimization on there, but let's not worry too much about that. So yeah, pressing the button and I stop in that piece of code, which is nice. But we have some other options in these breakpoints as well, where we can have a conditional stop there if we want. So if I do that, then you see it's giving us some hints there, but we could say if counter was greater than, what are we on, 24, let's do 30 just so we can be sure. So that should only stop now if we're on 30. So let's run that, and it should just run and not stop. And then I'm going to press it a couple of times. And if it's worked, come on, we can do it. There we are. Oh, good. Phew. That wasn't going to work then. So that stopped. So that conditional breakpoint could be quite useful as well, just to stop you from having to do that constant stepping in and out of code. So that's pretty cool. I like that. So if we go back to conditions, we can get rid of that now. So cancel that and delete that. There's an extra thing here called actions, and this is really handy. So you can put something in there just to say the button was pressed. And you see there's a tick box under here, so it's going to continue. So this is a tracing element that I've put in here. So if I hit enter to that and just press close, we run the code now. We watch over in this output window in the bottom right hand corner, and I know the text is probably going to be small, but when I press it, it's now saying the button was pressed in the output window. So that's coming out of the JTAG debugger side of things, I think, and giving us that that instant information in there that we've run into that particular part of the routine, which is dead handy. But it's even handier than that, of course it is. So if I go back to actions, one of the other things that we can do is, oops, it actually tells you here, you can actually insert the function that you're in. Now, obviously we've not got much in the way of functions, but if we put that in anyway, so I press the button, like that, and close. So now when we press the button, it says loop, and so we're in loop. And I press the button, so that can be handy once you've got quite a big program and you want to know where these things are coming from. It'll automatically insert the function name in there. But we can go further. So we can go back to actions and go back into this. What we can do is we can actually print out the value of that counter. So the counter is, and if you put these in curly brackets and put counter in there, enter to that and close. Then I'm going to press this button. Now we get the counter is 37. So we don't even need to stop the code anymore to be able to get that out. And I know that's kind of just using serial print commands from the code, but I think it's a bit more powerful than that. Couple that with the other things that you can do at this point. So yeah, I like that, 38. 39, 40. So yeah, I like that. And that's the top level of what you can do here. Actually, if you're doing the serial one, you can get the serial debugging option. You can get a bit more out, as I mentioned earlier. You can get the digital pin values. I think you can even set them serially there. And as I asked a question on the forum, and I think they're working currently on bringing that to these GDB, these hardware debuggers. But I'm guessing it's quite a big job. Saves all the compile uploads, exactly. And bring back printf, yeah, exactly. Print and print line, or converting everything to strings and concatenating stuff together. And yeah, it's so yeah, it's they can be set from the serial debugger at present. Yeah, exactly. So and I've not played much with the serial debugger, so I need to go back and have a go with some of that actually, just to see what it is you can get out. But there's quite a few videos, and Visual Micro themselves have got a whole YouTube channel, and there's, I don't know, 30 odd videos on there, really good videos taking you through these bit by bit. So well worth going and checking out their YouTube channel if you need to do that. So yeah, so I mean that's the top level of Visual Micro. And so if Visual Studio's where you want to be doing your work, then by all means this would be the perfect opportunity for you to do that. So I'm going to stop that from debugging. Let's hit the stop button and it will eventually do it. There we are. So that's finished. So if I switch back to my slides, which all that does is just get rid of the circuit above my head, and here, then we can look at PlatformIO. So this is exactly the same sort of elements that we had before, although it doesn't give you some of the extra bits that I showed you there, but we still get a very similar environment to work in. And again, it supports hundreds of different boards, but this one is a Visual Studio extension rather than Visual Code extension rather than Visual Studio extension. So if VS Code's where you like to live, and personally that's where I tend to do a lot of my work these days. I think I've got one project in Visual Studio, although that might change now. I have Visual Micro to rely on for Arduino. I think it's just got a couple of extra features. GDB gets powerful with more complex objects as it can expand and drill down, and the items it watches, yeah, it is. And I've just skimmed the surface on what this thing can do. There's a whole heap of stuff that you can get it to do. So yeah, I've got plenty of learning to do there as well. Again, we'll be able to set breakpoints, view variable values. It's free again. Oh, look, that's the end. And so let's switch over to VS Code, and we'll switch back to having a board on my head. So when you go ahead and grab the extension from the Visual Studio Code marketplace here, extension marketplace, then you'll get an extra little icon to choose from on the left-hand side. And then whenever you start up Visual Studio, then you get this PIO home page that shows up, and from there you can do new projects and import Arduino projects and open existing ones. And now I've already got one open because I didn't want to risk anything not working. But when you do that, one of the first things you notice, of course, is that you don't get, and again, it's similar to Visual Micro, you don't get just a plain INO file in a directory like you would for Arduino Studio. Then this is a full-on project structure. One of the small differences with PlatformIO is it likes to use CPP files rather than INO files. I think that's to do with IntelliSense and stuff. So that's one of the big differences there. And then you get this platform INI file. There's a little bit of setup to do for JTAG for a platform INI file here. You've got to add these two lines in that tell it to use the specific hardware debugger that you're using. So once you've done that, and again, there's a good tutorial on the PlatformIO website that you can follow along to get all this set up. There's actually another couple of steps before this as well. When you first plug in your ESP device, it automatically installs some drivers, but those drivers don't work with the OpenOCD. I think it's OpenOCD platform. You have to use a tool to be able to swap the driver out, and that's this Zadig or whatever you pronounce that as. And when you fire that up, I might as well show you that. So when you fire that up, then you can't get very far, but once you list all the devices, then you can. And there's a whole heap of devices in here, and you get these dual RS232HS interfaces. And again, it's probably quite small on your screen, so apologies for that. Thanks, Clifford. Thanks for the follow. Yeah, then you get this dual interface here, and you have to swap that out. So if I look at the interface 1, you can see that it's using this FTDI bus driver, and that's incompatible, so that's no good. You need to swap that out, which is what I've done here for this Win USB, and that just gives it access to everything at that stage. That FTDI thing strips out a bunch of stuff that the JTAG debugging software needs. So yeah, that's what that's going to do for you. But again, that's all part of the tutorials you can follow online. So yeah, once you've got that those couple of lines in your PlatformIO.ini file fired in, and obviously you've created a project at this point, then I've got my standard piece of code there with the button software in it. There's an extra header at the top that it likes to include, the Arduino.h, but that's not going to give us very much. The code is as it is. But down at the bottom here, we get some extra icons that we can use. And obviously the upload one and the verify ones and build are the ones we're going to be using. So I'm going to just upload that just to show you what that process looks like. So that's going to go through the process of building that out. Pete, grab this great tool for zooming live stuff. Zoom it. Yeah, in fact, I did that, and you know, it breaks it. If I do that now, then I don't know. Is that working properly for you on the stream? I tried it when I was recording earlier, and it all went horribly wrong. So if that's working, then that's fantastic. But I don't know. You'll have to tell me in the chat if that actually worked, and if it did, then I'll carry on using it. And if it didn't, then I won't, obviously. So that's busy uploading that. That's finished. And again, all being well, I press that button, then we have an LED lighting up. So that works, which is good. But as in with Visual Studio Code, we have a debug. Yeah, that worked. Oh, good. Well, I'll carry on using it then. So we have a debug tab here that we can switch to, and we get a bunch of stuff in here that is extra, including this memory and registers and peripherals and a disassembly as well, and variables and watch. But I can hit this start debugging, and I'm not sure if there's a way that I can get it to just debug. I think we can do the skip pre-debug section there, which skips the build, I think. So I've not tried doing that actually. So perhaps I'll give it a go. But that's sent that down, and what we've got at the moment is that it's just attaching the debugger to the ESP and going through a little bit of setup. And what it should do is just stop the code in the setup routine automatically. All being well, eventually. There's actually stuff happening. If we click this debug console, we see there's a bunch of stuff happening here. And I don't like the fact that there's a whole heap of red stuff in there. It doesn't look like there's a problem with it, actually. It just, they used red. I don't know why you would. And it stopped. So that's our code stopped. And obviously at this point we can do the same. We can F10 through. It seems a little bit slower to me than Visual Micro. And we can run that. Let that carry on. That could be my computer now, to be honest. So that's good. And then just as in Visual Micro, I can add a breakpoint, and the whole code stops at that breakpoint, which is great. And then you can see over here, that's saying optimized out as well. Actually, I don't know where the optimization settings are. I'm guessing probably you stick them in that INI file. I've not got that far with this yet. But if I F10 over that, then yeah, then there we are. Then button states 1. So we've got that same thing. and I can get rid of that breakpoint and stick another breakpoint in here and run the code back up again. Let that finish running. That should be running now. I'll press it, then we should have the code stop again. There we are. So that's very similar. Now there is I deleted it. Oops. Go in. There we are. So we can edit this breakpoint and put expressions in there as well. So we should be able to do the same thing again, I guess. Counter is greater than, I don't know what we're on actually at the moment. Oh, we're on 0, of course, because that's going to be the first time I've pressed it. So all right, so 5. Let's see if that actually works. Run this up. So that should be 2. Looked like it was going to do something there. I think it knew. It passed over it, didn't it? 3, 4, 5, 6. Are you going to stop? Oh, there we go. There we are. So that does work. So we get the same expressions in there as well, but what we don't get is that nice ability to be able to squirt out stuff into the output window, as far as I can tell anyway. Obviously, if anybody's watching and they've spotted how you do that, then tell me, because it would be good to be able to figure that out. And I've not played with this disassembly section in here, but I've done quite a lot of assembler back in the past with microchip pick, so it probably wouldn't scare me too much, but there's going to be a lot of stuff in there that I don't have any control of, and our little tiny program is going to be a very small part of that. So let's not go into that too much. And yeah, there's no real point in going too much deeper into this at the moment, but you can see that you've now got a full environment rather than using Arduino IDE. Then obviously when you're in here, then the good thing about both of these is that we can do serial dot, and we're going to get IntelliSense at this point as well, which you don't get in the Arduino IDE. And then you get all of the rest of the goodness with the other extensions you want to install, and GitHub, and the fact that this is tiny is useful too. So yeah, all of those things coupled together just make this a far nicer environment to use than Arduino IDE. So yeah, never go back, basically. If you go ahead and modify this, then it tends to throw a bit of a wobbly as well, so it probably will. Will it throw a wobbly when I try and continue? No, it's all right for now. But if I try and reattach a new debugging to that, then it's going to complain. Certainly Visual Micro complains as well, which is good, because if these line numbers are out, then you're going to be debugging the wrong line. You're not going to know what it's doing. So they are the main parts of debugging, and again, I'm not going to delve really deep into this for this particular video. I just wanted to give you an overview of how it works and what it looks like, and some of the features that you can get out of that. So I'm hoping that that gave you that sort of a high level view of what you can see. So if I switch back to my slides now. So here's some links, and again I'll publish this slide deck. Pick an AVR bare bones, yeah, absolutely. I was doing that all in assembler. That Royal Mail stamp vending machine that I mentioned earlier, that was all in assembler. Many thousands of lines of assembler. It was like reading the Matrix. Yeah, so go and grab the Arduino IDE. You can do a lot of what you need to. I started with the Arduino IDE to get started with the ESP. And then you can download libraries and the boards from in there, and you kind of know it's going to work. But you do have that facility directly in Visual Micro. I think you have it in PlatformIO as well to download those libraries directly. But it kind of felt more natural to do it in the IDE to me. That's the dev kit that I bought, and in fact, if I get that up in my browser, hello, are you going to do it or what? There we go. My poor PC, it really is struggling. So this is the dev kit that I bought, and so yeah, $7.99 each. Oh, go away. You didn't make much sense to go down that 2 pieces for £16.49 when you can just buy 2 for 15 quid. Or 16 quid. I think that was actually more expensive when I first started to look. But yeah, so you can have that for tomorrow. The the only small downside with this is, and mine's worse than this actually. See those pin numbers D32, D35? They're almost indistinguishable from each other on mine, and that's what you get for buying one that's slightly lower quality. That's a good image of a better board, I think. So, oh, thank you, Saginamal98 for the follow. Thank you very much. So yeah, so that's that. So close that away. This is the board that I bought. I know that Clifford was asking about this earlier. And come on. So I went to DigiKey to get this, and they've got them in stock. And so I think I ordered it on a Monday, and it arrived by the Thursday. So, and that's come from America. So that was, in fact, no, it was a Sunday I ordered it, and they packed it on the Monday, I think, and I got it by the Thursday. So it was pretty impressive work, and their packaging was cool as well. It's all recyclable packaging, and I didn't have to pay any import duty. And if you order over, I think it's 30 quid, 30 quid's worth of kit, then they'll ship it free as well from America. So I ordered this, and I ordered a couple of these, and I ordered an Azure IoT board as well. So this is an ESP32. Oh, that's terrible. Look, that's done to me. Oh, I look wonderful now. Hopefully that'll sort itself out. Yeah, there we are. Good. Yeah, so this is a bit similar to the MX chip, the AZ3166, I think it is. It's a bit similar to that, but it uses this ESP32, and there's some libraries that you can go ahead and install to get you started with that, and it's got a couple of buttons on it and an OLED and stuff like that. So that's pretty cool. So yeah, I ordered one of those and two of these, and that took me over the 30 quid, and I got my free postage and packaging, so that was quite handy. So that's that. And then yeah, Visual Micro, so you can go ahead and go to I've already prepared these ones earlier. So you go to the Visual Micro page, and there's a really well-attended forum in there. So they're really receptive in there, really great people working in there. So yeah, if you have any issues at all, then just go ahead and go in there. They've got a blog and a FAQ and a help with debugging. So there's some common stuff, and I came up against a couple of these things, and they helped me to get over those in there. But yeah, so go ahead and look at that. And then PlatformIO, so you can go to that and you can install it, but that just takes you to the extension page, I think. But do it all from Visual Studio Code, basically. But there's a heap of PlatformIO videos on YouTube as well, so you can go and grab them. So that's them. And then if you want to know a bit more about JTAG, then you can read this if you want to. I'll pull this in here. So yeah, they're talking about boundary scans, which is this idea of being able to check the pins and what they're doing. And then it explains what these interface signals are doing, and yeah, test mode select sampling on the rising edge to determine the next state. There's a YouTube video I started watching about how this works deep down, and it's got the whole state machine of how JTAG works. The guy is obviously really knowledgeable in that area, and some of that I think is this state machine that you can see here, but he goes through and explains how that process works. And yeah, it's pretty impressive talk actually. So you can just do a search for JTAG debugging, and I'm sure you'll find it on there. Or just reach out and I'll send you the link. So yeah, let's say it's an IEEE standard here as well, but it doesn't give you the standard for exactly how each manufacturer utilizes this standard, because they're all going to do something different based on their specific device. But at least these pin names and functions are standardized. So that's good. So if you want to get in touch with me, then there are many ways. Twitter's always the best one. Just send me a message on Twitter, and I'll respond to that quite quickly. But feel free to email me there at pete@pjgcreations.co.uk. I've got a blog that I do most of my blogging there on petecodes.co.uk. So go ahead and check that out, and my company website, PJG Creations too. Up here in Nottingham, then I also run Knots IoT, and I co-organise .NET Knots, and we have a new person on the organisation panel now, Jess White, who's just joined today. You may have seen that notification pop up on Twitter. Jess is fab. We're really lucky to have her involved with .NET Not, so we're happy with that. And they're obviously running remotely on Zoom as it happens. And we have a meetup at the end of the month for .NET Nots, and then one scheduled for Nots IoT in the middle of next month as well. So keep your eyes out for them. And then Nots Dev Workshop, which isn't currently running, which, as the name suggests, is a workshop-based meetup, but it tends to be easier to run those in person. So we'll see what happens with those. I'm also a member, one of the board of directors of LATI, which is a Loughborough-based high-tech meetup group. We tend to do everything in person, so we're not doing much remote on there either. And myself, along with a few other people, we record the Agile Engineering podcast. So if you've got any interest in DevOps and Agile Engineering, then go and check that out. And then once this Twitch stream's finished, then I'll go ahead and upload these slides, and you can get those at that bit.ly there, PJG ESP32 JTAG Twitch. You'll be able to download the slides for that. So with that, if there's any questions, anybody got anything they want to put in the chat? I'll switch to now you'll be able to hear me as well if I do that. So yeah, feel free to ask any questions in the chat if you've got anything you want to say or any suggestions for me. Obviously, I'd like some feedback on what I've done today. It kind of feels like I've given a talk rather than what I see most people doing on Twitch, which is live coding. But I hope you don't mind the way that I've done it. I know a lot of people put music in the background as well, but I was a little bit worried that my Surface wouldn't be able to handle putting Spotify in the background. And I've also heard some people have been struggling with DRM music on there, so I don't want to get insta-banned before I even get going. Yeah, so thanks to everybody who came along and watched the stream. I hope you got out of it what you were expecting to get out of it. I'm going to try and do some more streams now as well, with some other stuff as well. I'll just think exactly what I need to do for that. But oh, no sound, he's saying. I've got the sound on there though. Let me go back to this. There, so hopefully you've got sound now, and a board above my head as well. Boop, boop, boop. Apologies for that. But if anybody's got any questions, now that you can hear me, I don't know why the sound wasn't working there. But either way, if you've got any questions, then feel free to put them in the chat there. I'll try my best to answer them. But you can always reach out to me on Twitter, as I've said. And obviously, if you've got any feedback other than the lack of sound problems that I've had with that, but that's what you get for not quite setting up the scenes properly. And yeah, so thanks very much for everybody for coming along. Do let me know if you've got any suggestions for how I should make this better. And I'll hopefully see you again soon. So thanks very much for coming. Oh, I'm back now anyway. I think I'm dealing with the fact that my stream chat is delayed quite a lot, and I guess there must be a way of fixing that somehow. I'm not quite sure why. I mean, that's my stream chat in OBS, so there must be a way of improving that here somewhere. I don't know how you do that. I need to talk to one of the expert streamers like Layla or Jeff Fritz, so I don't know what to do about that. But yeah, that's good. Well, I hope that I'm not going to chop you off just as you're going to ask some questions rather. But oh, good. Thanks for the walkthrough and catch up. Yes, brilliant. Absolutely, yeah. Please do, Simon. I appreciate you coming along. It's good to have you along. So yeah, all right. Thanks very much, everyone, and I'll catch you again soon. So see you later. Bye.